Assalamu alaikum, namaste, Sriyakal. Welcome back to my channel Vision Tutorials Khan. Please like, subscribe and share. We will be learning about the basics of arithmetic progression series. I will be covering the 5 important concepts of arithmetic progression series in this video. We will be learning the definition of arithmetic progression series, the notation of arithmetic progression series, the derivation for the n term of an arithmetic progression series, derivation for the sum of arithmetic progression series, and fifth we will be learning about the miscellaneous property of the arithmetic progression series. So let's begin the video. Before getting into the definition of arithmetic progression series, we need to learn about the mathematical pattern. A set of numbers related to each other in particular manner or rule, and such manner or rule is called as a mathematical pattern. We have 3 major mathematical patterns. We have arithmetic pattern, we have geometrical pattern, we have Fibonacci series. The arithmetic pattern is called as an arithmetic progression series. So coming to the arithmetic progression series definition, arithmetic progression series is defined as a set of numbers where the difference between two consecutive numbers is constant. So to understand the definition, let us consider this example. Example 1, we will consider the series 2, 4, 6, 8, 10, so on. In definition of arithmetic progression series, we use the term called consecutive. Consecutive means it's a number coming next to each other without having gap between numbers. So if you consider this series, the consecutive number for 2 is 4, the consecutive number for 4 is 6, the consecutive number for 6 is 8, the consecutive number for 8 is 10, and so on. As by definition, we will take difference between the two consecutive numbers. So here the difference between 4 minus 2 is 2. The difference between these two consecutive numbers, 6 minus 4 is 2. The difference between these two consecutive numbers, 8 minus 6 is 2. The difference between these two consecutive numbers, 10 minus 8 is equal to 2. So here common difference d is equal to 2. This set of an even number as arranged in an ascending order is an example for arithmetic progression series. Let us consider example 2, where we have the set of numbers 3, 3, 3, 3, etc. As by definition, we need to check whether the series is in arithmetic progression or not. We will take the difference between the two consecutive numbers. The difference between these two consecutive numbers, 3 minus 3 is equal to 0. The difference between these two consecutive numbers, 3 minus 3 is equal to 0. The difference between these two consecutive numbers, 3 minus 3 is equal to 0. Since the common difference is equal to 0, the series is an arithmetic progression series. Consider another example where we will consider and descending numbers are in a descending order. Let us consider 30, 20, 10, 0, minus 10, etc. The difference between these two consecutive numbers, 20 minus 30 is equal to minus 10. The difference between these two consecutive numbers, 10 minus 20 is equal to minus 10. The difference between these two consecutive numbers is minus 10. The difference between these two consecutive numbers is minus 10. Therefore, the common difference is minus 10. This series is also an example. Coming to the notation of an arithmetic progression series. Any arithmetic progression series is basically denoted by the term as a plus d, a plus 2d, a plus 3d, etc. Any arithmetic progression series, if we tell, for any problem related questions, we will be using this type of series to denote an arithmetic progression series. Since the difference between these two consecutive number is d, the difference between these two consecutive number is d, the difference between these two consecutive number is d. Since if we take a plus 3d minus a minus of 2d, we take a cancel, 3d minus 2d is d. Therefore, any arithmetic progression series is denoted by a plus d, a plus 2d, a plus 3d, and so on. The first term of an arithmetic progression series, as it is called first term, we have T stands for term T1. We write it as T1. T1 is stand for first term of an arithmetic progression series, which is also given as A1, which is also given as A. So small letter a is used to denote the first term of an arithmetic progression series. The common difference of an arithmetic progression series is denoted by small letter d. The n term of an arithmetic progression series. The n term of an arithmetic progression series is given as Tn, which stand for 10th nth term, which is given as an. Nth term of an arithmetic progression series is basically given as an. The last term of an arithmetic progression series is denoted by n. First term a, last term n. The sum of an arithmetic progression series is denoted by capital S and small n. These are the notations we use for arithmetic progression series. Derivation of the nth term of an arithmetic progression series. Basically in board examination they will ask as prove an is equal to a plus n minus 1 into d. So the solution or the derivation is as follows. We need to write as let the arithmetic progression series be a1, a1, a2, a3, a4, a5, etc. with a common difference given as d. The first term of an AP series is given as a1. First term is a1, which is equal to a, as we have learned in the notation of arithmetic progression series. This second term of an AP series, the second term of an AP series, here second term is a2, the second term of an AP series. As by the definition we know, the difference between the two consecutive terms of an arithmetic progression series is denoted by a common difference d. So a2 is equal to the first term a1 plus d. a1 is equal to a, so we can write as a plus d. Give it as equation 1. The third term of an AP series is given as a3, which is equal to the second term a2 plus b. The second term a2 is equal to a plus d. So we can write as a2 is equal to a plus d. Right, a2 is a plus d plus d. We can write as a plus 2d. Right, the third term of an arithmetic progression series is given as a plus 2d. So third term is a plus 2d. The second term is here is a plus d. This is equation 1. This is equation 2. Or we can take it as we'll call this as equation 1, this as equation 2, this as equation 3. This is same. So equation 2. Okay. Equation 1, equation 2, equation 3. First term is given as a, second term is given as a plus d, third term is given as a plus 2d. The fourth term of an AP series is given as third term plus d. Third term is a plus 2d. So a plus 2d, write it in the bracket, plus d, we have a plus 3d. Call it as equation 4. Since we have first term a1 is equal to a, we can write it as a plus 1. So 1 minus 1 times of d. 1 minus 1 is 0. 0 multiplied by d is 0. So a1 is equal to a. Second term can also be written as what we have, a2 is equal to a plus d we have, right? We can write as a plus d, which can be written as 2 minus 1 times of d. This is a, this is a plus d, which can be written as 2 minus 1 is 1. So coefficient of d is 1, coefficient of d is 1. Third term is given as a3 is equal to a plus 2d, which can be written as 3 minus 1 times of d. 3 minus 1 times of b, which is equal to a plus 2d. It goes on. Similarly, by generalizing, we have an is equal to a. Since in all the above equations we have a first term remains constant, so a term remains constant. If it is 1, we take 1 minus 1. If it is 2, we take 2 minus 1. If it is 3, we take 3 minus 1. Since it is n, we take n minus 1 times of d. So this is how we prove the n term of an arithmetic progression. On to the fourth important concept of arithmetic progression series is about the sum of arithmetic progression series. So basically in examination they will ask as prove Sn is equal to n by 2 times of a plus l. We need to prove n by 2 is equal to a plus l. So let us come to the solution part. In solution, we basically have, as we know that let AP series be a comma a plus d comma a plus 2d comma a plus 3d, etc., where first term t1 is a, this is second term, this is third term, this is fourth term, and goes on. The sum of an AP series is denoted by Sn, right? Sn is nothing but the sum of an arithmetic progression series. We also have the last term. Of an AP series given as L. Last term is given as L. Second term is denoted by L minus D. Second last term is given as L minus D. L minus D plus D gives last term L. Last third term is denoted by L minus 2D. Right? So if we consider L minus 2D, L minus D, L minus 2D plus D, L minus D, L minus D plus D, L. So this is the last term, last second term, this is the last term, this is the last second term, this is last from last third term, last from last second term, from last, this is last term. L minus D, L minus 2D. So the concept comes from there. Coming to the sum of an arithmetic progression series. The sum of an arithmetic progression series, Sn is equal to, add all the terms of arithmetic progression series. A plus D, A plus 2D, A plus 3D, etc. plus L minus 3D, last but fourth term, plus L minus 2D plus L minus D plus L. Last term, last by second term, last by third term, last by fourth term. First term, second term, third term, fourth term, etc. Call this as equation 1. Reverse the right hand side of the equation 1 and rewrite. Reverse right hand side of equation 1 and rewrite. What we have? Left hand remains same, Sn. So last comes first. L plus L minus D plus L minus 2D plus L minus 3D. Right? Plus A plus 3D, A plus 2D, A plus D plus A. What it is? So call this as equation 2. Now add equation 1 and equation 2. Add equation 1 and equation 2. Add these two terms, 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 and add these two terms and add this term. We get A plus L. Sn plus Sn. LHS side is 2Sn. Right hand side A plus L. A plus L minus D. Plus D and D cancel. We get A plus L. Minus 2D cancel. We get A plus L. Plus 3D minus 3D cancel. We get A plus L. So on. Minus 3D plus 3D. Minus 2D plus 2D. Minus D plus D cancel. So we get A plus L. The second term A plus L. Third term A plus L. Last term A plus L. Right. Since we have n number of digits in an arithmetic progression series, A plus L repeats n times. So we can also write as 2Sn is equal to n times of A plus L. Also, Sn is equal to n by 2 times of A plus L. Here A is the first term, L is the last term. L is the last term, which is given as A plus n minus 1 into D. Therefore, Sn can also be written as n by 2 times of 2A plus n minus 1 times of D. A plus n minus 1 to D gives A plus n minus 1 to D. And miscellaneous property for arithmetic progression series. In examination, usually they ask to prove an is equal to half times of an plus 1 plus an minus 1. To solve this type of problems, let us consider let us solve it by step. So solution, we have, let an AP series be A plus D, A plus 2D, A plus 3D, etc. Right, here usually we have, this is usually given as term 1, this is term 2, this is term 3, this is term 4. Right, let n is equal to 3. Right, so A3 we have A plus 2D. Call it as equation, or multiply 2 on both sides of equation. We get 2A3 is equal to 2 times of A plus 2D. Give it as equation 1. This left hand side. Okay. Now we have an plus 1, an minus 1. An plus 1 is equal to A3 plus 1 is equal to A4. Right. A4 is A plus 3D. An minus 1 is equal to A3 minus 1 is equal to A2. A2 is equal to A plus D. Call it as equation A. Equation B. Add equation A plus equation B. We get an plus 1 plus an minus 1 is equal to A plus 3D. A plus n minus 1 is equal to A plus 3D. An minus 1 is equal to A plus D plus D. Right, we get 2A plus 4D is equal to 2 times of A plus 2D, which is equation 2. Call this as equation 1, this is equation 2, this is nothing but an plus 1 plus n minus 1. Since RHS of equation 1 and equation 2 are same, thus LHS are also same. That is A2 times of A plus 2D, 2 times of A plus 2D. The RHS of equation 1 is equal to RHS of equation 2. Therefore, we have 2 times of A3 is equal to n plus 1 is nothing but 3 plus 1. Here A3 is nothing but an. Right? N is 3. A3 is an. Therefore, we have an is equal to n plus 1 plus n minus 1. An is equal to n plus 1 as a n minus 1 times of 2, hence root. This is one type of miscellaneous property of arithmetic progression series. We can solve n variety of these kind of problems just by taking off the arithmetic progression series a plus d, a plus 2d, a plus 3d. Take a left hand side and right hand side partially and solve it. So in next video, we will be solving couple of problems in arithmetic progression series. Thank you.